In this question, we are going to calculate the average power to accelerate this mass from rest to certain height, and what will be the power delivered by the motor that will perform this work. Okay, so as you see that this question, it states that it is moving with constant acceleration, so it means that its velocity is increasing uniformly. Secondly, as you see that it is starting from rest, so it means it doesn't have any kinetic energy in the beginning. So how its position will vary, you have already covered it in A1, that in a first second it will cover less distance than in the next second it will cover more distance, because they are saying in 2 seconds. So speed at the t is equal to 2 seconds. At this instant of time, the speed of this block is, the velocity is how much? 4 meter per second. So if we draw the graph, okay, because why I'm doing this, because to find out the power, if we go back the simple definition of the power, that rate at which work is done, so this work is not necessarily always equals to the gain in potential energy. As in this case, it is not only gain in potential energy but also gain in kinetic energy. According to the work energy principle, work done is equals to the change of energy, and what energy is? Change in potential energy plus the change in kinetic energy divided by, dear students, the time taken, that is 2 seconds. Now if we go further and deep dive in equation solving, that how much energy does it have, like the initial energy is 0 but final energy, potential energy, is mgh. So this is a change in potential energy, or in other words, it is the gain in potential energy, plus 1 over 2 mv square minus 0, because initially I told you it doesn't have any kinetic energy, so this is the gain in kinetic energy and this is a gain in gravitational potential energy. Okay, and divided by time taken, right? This is a proper equation and the time is 2 seconds. So if we draw this motion in a form of graph, so this is the velocity time graph, and don't forget the slope or a gradient of velocity time graph gives us acceleration. So this will be the graph, a uniformly increasing graph, right? And students, even if you are wondering that why we are even drawing the velocity time graph, the reason is, you know, this factor height, the height is not given, and as it is the uniformly accelerated motion, so we can apply Suvat to find out the height. And to and to apply Suvat equations, you have to know acceleration. And acceleration we know is a rise over run. So acceleration will be equals to delta V over delta T. That is of course 4 minus 2 over 2 minus 1, that is 2 meter per second square. So this is an acceleration with which it is continuously moving, accelerating up. So now we can apply Suvat. So to find height, this height h, let's call it h, vertical height. To find this, you can apply either h s is equals to ut plus half at square, or you can also apply v square is equals to u square plus 2as. All equations will give you the same answer. What is a vertical displacement covered? That is a height h. Initial velocity is 0. So if we plug the values, so 1 over 2 into acceleration is 2, we just calculated in time is 2 seconds. So height is equals to 4 meter. It means in the time span of 2 seconds it has covered vertically 4 meters. And now we have all the values, so if you're ready we can plug the values here. And we are not given the mass specific value, it is just m that we will write here. So m into 10 into height is 4 plus 1 over 2 into m. Velocity at the 2 second was 2, so no, it was 4. So 4 square divided by 2 second. So average power is equals to 40 m plus 16 over 2 is 8 and 8m divided by 2, and that is 48 m. divided by 2, and that should be 24 m, and units is watts is our final answer, so that must be 24 m, option B. I hope you understand this solution.